Students, today we will discuss about how to solve max sign problem using simulated annealing search technique. So let us see the objective function for max sign problem. F of x is equal to sine of pi into x dash by 2 power d, where x dash is the integer representation of the x vector. So in the question they ask to find out the best solution for 8 dimensions, d is equal to 8 and the number of iterations 10 and the initial temperature as 10. Okay, so let us see how we will perform the minimization process. Okay, minimization process. Let us see one by one. So we have already seen how to implement the max sign problem in our previous video. So let us write directly. You can see the max sign problem. So let us see the syntax for max sign problem. The syntax is optim function. This function is already available in R package. Optim function, and you have to pass 1, 2, 3, 4, 5 input arguments. The first argument S is the initial value. S is the initial value, and this one is our objective function. Second argument is you have to pass the objective function, and the third one is change function. You have to define the change function. Okay, this simulated annealing, it is a improvised version of the hill climbing. Here the difference is we will use a metropolis function and a parameter called t. Okay, which you will discuss in the theory class. GR means change function, and the next argument you have to supply is simulated annealing. Actually optimum is a generalized function. You have to specify the method as simulated annealing, SANN, and finally the control list parameters. Here the control parameters are specified in the form of a list structure. Okay, in this list you have to specify the initial, what is the initial temperature T, and what is the maximum number of iterations, and then T max, that means how many evaluation we have to perform for each temperature. Okay, if you don't supply means the default values for temperature is 10 and T max is 10. Okay, this is the one you have to understand. Okay, so after understanding the syntax of this simulated annealing function, let us define one argument after another argument. So first we will implement the max sign function, which we have to pass as a second input argument. This discussion is already seen, so you need to understand this. By default the optim function is performs the minimization only. By default the optim function performs minimization. So if you want to perform maximization, you have to change. So change like this. Okay, so minimization of, if you want to find out the maximization of this sine function, what we have to do is we have to change the objective function as 1 divided by, if you do that, it is same as finding the maximum value. Okay, just we are changing the function to 1 by sine function. Okay, so here the implementation is clearly understandable. You can see this. And the next thing is here x is a vector, binary vector, and this binary vector, it will be converted into decimal value, and then it is processed and sine function is applied. So pi value is 180 degrees we have given. So we want to find out the maximum value for this sine function. So if you modify the function like this, 1 by divided by sine, you will get maximum value. Okay. So this function, for this function, if you want to, if you apply the minimization, you will get the best optimum positive value. Okay, you will get maximum value because we have inversed this function. So I think you understood. So d is equal to 8 bits that we have defined, and then the initial solution, yes, you can see that is the first argument. So initially we are starting at the origin 0, 0, 0 of dimension d. You need to understand that our maxime function, the input is a binary vector, okay, binary vector of dimension 8, okay. So you cannot directly give to the binary vector to the sine function, so you need to perform the conversion, integer version. So for that we are using this function. This function is available in the library package, and we define the initial solution, and then we have to define the control parameters. So everything we have to pass as a list. So the syntax for list creation is list, you have to use list function. So define all the control parameters like maximum number of iterations. So I put 10,000. So the temperature, what is the temperature? We have to start the algorithm. So it is 10. Okay, you want to start 20 also. At 20 degrees, you can start the algorithm. Slowly, for each iteration, the algorithm, the temperature value decreases. So here the logic is, as the temperature is decreased, you will get optimum solution. Okay, for each temperature, how many evaluation has to be done? So that is represented as T max, and you put report is equal to 1, trace is equal to true. Okay, so all these parameters you enclose in the list data structure C, and then you have to pass to the optimum function. We define S, and then maxime function, and then the change function you have to define. So that means we will see the change function, and then finally the third argument is fourth argument is method. What type of method we want to use? Here we are performing simulated annealing. So the name should be SANN, and then finally control list parameter C. So you can see the C is a list. Okay, and then we have to define the change. Okay, change function. Change function means it is a step change function. Okay, so I will tell. So we already told you, you want to generate a new solution. New solution is always equal to x of old solution plus step change plus some change value. So this is implemented as a function. You have to pass to this argument, and this is implemented like this. So we already discussed it earlier also in Monte Carlo search technique also. You have to pass some old value. For this old value, you will perform some change. Okay, how the change is added? This is a small change is added to the old value. Is here we will take a sample from normal distribution function with mean 0 and 1, and that step is rounded off because we already told it is a binary variable. X is a variable, so binary variable. So we will round it either to 0 or 1, and then that is added to this parameter, the old solution. You can see this step. This is the actual step here. What we are writing is this one. So old value plus some change. Here the change is step. Okay, this step is a sampled value from the normal distribution, and you will get the new value. Sometimes this value, it may exceed the boundaries, so you may get the boundaries other than 0 and 1. In such a case, you need to perform the clipping operation. Okay, if it is less than 0 means you have to clip to 0. If it is greater than 1 means you have to clip to 1. So that is the thing, that is the logic here. Okay, once it is done, so you have to pass the new value, new solution to this function, and then this function will evaluate. Okay, so in this way the algorithm will run in a stepwise manner. So you have to define the change function. Here we have implemented the change function like this, and this optimum function, simulated annealing, it will throw you the S1 list. So for finding the best value, you can use the parameter element S1 $parameter. Similarly, S1 is the object. We want to find out the best value, S1 dot value. Okay. So let us see the output. Okay. Therefore, at this step we got the maximum value. Okay, maximum of 4. So in this way, you will understand the algorithm. So actually, it is a maximization problem. Maximization of sine function. Okay, maximization of sine function. If you want minimization means you just modify this function. Okay, if you modify this function, you will get the minimum value of sine. So this is the minimum value. Okay, at this you will get minimum value. So you can try it. This is how you will implement the algorithm. Okay, let us try. So the maximum value, minimum value. We implement the max sine function, and then the step change function, and then we are passing to the optimum value. Okay, students.